So let me tell you what are they now. Very important things. So last time we have do many things, but I will go through it piece by piece without the same order that you find in the last practice. Okay. So if you can still look at the old notes, okay, you can download it and take a look. By the end, before we do the reboot, we do this thing. Okay, we call it I name it rob, or someone call it rob, whatever things. Okay, this is called a GNU bootloader. Okay, so this is a bootloader. Its job is to write a boot code into the front of the hard disk. Okay, the first 512 bytes. Okay, so what they are doing is actually load the code so that previously you see the little guys that I do the edit and I can see the boot image name. That's it. That is that guy. Okay, so without doing that step, you cannot put up your image. Okay, and this command you will do it quite frequent later because later on maybe you change some of the configuration of your boots. Let's say you want to create more boots entries, then you will do this again and again whenever you try to make a new boot screen. Okay, but today we won't change this. Then previously we have the start of the booting of the ISO file, the installer. When we try to set it, we will do a fdisk. Fdisk is called a fixed disk, right? How many of you have do this command before? Fdisk. I work on it on DOS already. DOS have fdisk, okay? We have the fdisk, and later on I will tell you what the fdisk is. But after finish the fdisk, we have a NTFS. So they are the formats. Okay, so you can try. You can try have a USB and say that MKFS over that USB device. Then you can change to whatever file system you want. They have several options. So where can you find the options? Zoom in, and then you type MKFS dot and type the tab. Then you can already find some the Minix. Last time I tell you about the Minix. Extend 4, extend 3, extend 2, okay, the differences are these two are quite big, these two are very small. Just the extend 2 and extend 3, the difference is a journaling file system. Who have heard of link journaling? Only one, no, one, two. Journaling, this journaling file system. This without journal, this has a journal. Okay, so this course by the end, the second last week, I will tell you what exactly is a journaling file system. Okay, and CRAMFS, the CRAMFS is for embedded systems, so and so forth. If you want to have the format capability for, let's say, FAT32, then you can download the software that you want by using Emerge. Okay, so let's say the Emerge search MKFS. It should give me some. Oops, what? Thank you. Yeah. Format. Wow. Thank you. FAT32. What? Okay, this image is beautiful, huh? Yeah, so later I'll find it for you. I cannot find it now. Alright, so what are the missing part here is the MK swap. Okay, so what is MK swap? MK swap is very important. Okay, it actually turn on the virtual memory support for your system. Okay, so in a computer, okay, let's say Windows, it uses what we call page file. Okay, later on you can do a Google search what is page file on Windows. Okay, it's actually ask a hard disk to support the virtual memory so that you can extend the memory beyond your physical limit. Let's say the physical limit is 8 GB. You can extend it to, let's say you use the SSD, right? SSD you have a 128 GB. Okay, you give a half of it to virtual memory, then you will have 64 GB memory extension. Okay, this is called swap. Okay, I remember that my computer here also have a swap support. Let me see, memory, swap use. Here, can you see this? Swap use. It's used so many swap here. So that means that I already launched enough application that originally I have 8 GB I already used up. Okay, but I don't know why I have free memory. Okay, but it still uses swap. Okay, maybe some weeks before, because how many days I didn't report it? Maybe a free uptime or free 1 month. Okay, I didn't report it. Okay, so maybe sometimes I reach the peak of the use of the memory. Okay, then some of the processes forced to use the swap, and now there is free memory, is still stay on the swap. Okay. So this is the swap, very important. You can turn it off, no problem. Okay. The penalty that you turn it off, you never call mk swap. Later on we have a command called swap on. Okay. You never turn it on. What will happen? Let's say you have only a 4 GB of RAM, and you have 64-bit computer. You can only allocate memory up to 4 GB. That's all. Okay. You cannot go beyond that. But if you have swap support, you can go beyond your physical limit. Okay. So this is swap, and then we do one thing, right? You use this ISO to put up the system, and the system gives you this kind of a basic things for your system to go on with the installation. Basically, they are read-only, right? It's not on your hard disk, not copied to your hard disk yet, and it's provide you some binaries in a /bin directory for you to do the fdisk, immerse, so and so forth. No, immerse is not. Fdisk, ls, rm, whatever things you want. Okay, and what are the applications that fit into your hard disk? It is by the time that you type this command. Okay, you can go to refer to the notes. You have this command, mount SDA4 and then Gen2. Okay, so if you remember, without doing this, okay, I already see some people here fail to execute this command. I don't know why. And then while you're doing installation, the system tell you that run out of memory. Who have it? Run out of memory. Yeah. I think this area has 1 or 2 guys. You, right? No, he. I remember the guy using VMware, right? It said, oh, fail to do something, and then suddenly extract something, boom, it says running out of memory. Okay, so first of all, this command is actually a linkage. Okay, this is your ISO files system. The ISO, when you put up, it gives you a file system, and which is read only. Okay, then you create a new directory called /mount/gen2. You call the command mount. It means that the hard disk that you create using fdisk, the partition that you create, actually attached to this directory. Now this is a hard disk, enables you to write files. So when you extract to here, but not here. So why is that when you are extract in the wrong directory? Let's say you extract to this green area, it will say memory. What is that? It's running out of memory. Yeah, it says running out of memory. Why? Because we have a very powerful support by this ISO that if find that you want to save something, he will find space for you. The way is to create a RAM disk. Use RAM, treat RAM as a disk. Okay, so you can already find what are the RAM disks. Already there. Let's check. To see whether you have this. Where? Oh, here. It's LS. No, it didn't create yet. No, didn't create yet. Yeah. In my Ubuntu, they already created with the RAM. It's called DV RAM 0, RAM 1, RAM 2. Okay, they are created RAM disks. Okay, and those RAM disks you can format it, but when you use it, that means that you are using up your memory. Okay. Later on we will explore one RAM disk. Okay. Then here. Yeah. See. I don't know whether is this made in China? No manufacturing place. Oh, Korean there. Yeah, maybe North Korea. Okay. So yeah. And then you do the following: you download this file, okay, or copy it from USB and extract the things. Now you extract it here, okay. It is a hard disk, so that's why there's no problem. Okay, so the USB stuff is here. All right. Now what is going on is actually you're creating 2 kind of similar file system. One is read-only. The green guy is read-only because it's the ISO file system. The red guy is read-write, and they behave similarly. They still have a here I didn't write. Oh, why? Copy and paste. I should be one is bin. Bin, etc, USR. They just give you all the directory, and the next step you are doing is actually changing the roots of your executing shell. Remember what I say. Change the roots of your executing shell. So what is the meaning? It means that you want to change the root directory, go to here, so that whenever you work with this file system, it's actually treating as your home, your roots, ignoring all previous locations. Why I say that it is the shell only, okay? So we can do it together. Did you launch your Gen 2? No, okay? We can do it together. Type 1 key, okay? I don't know how in Mac because I need the alternate key. It's alternate F1, alternate F2, alternate F3. Let's say you already put it up, and in this screen you type alternate F2. How can I type it in Mac? Alternate F2? Ah, good. Yeah. In Mac it is a function option, and F2. Okay. Can you see it? It's 1, 2, 3, 4, 5, 6, and then 07. 1, 2, 3, 4, 5, 6, and then go back to 1. Okay, so we call it virtual console. Virtual console. So you can still log in here. Yeah, in Mac it is a function alternate. Okay, in Windows it's just alternate. I mean the host. Alternate F1, alternate F2. Okay, so function alternate. So you can see I'm switching the console as if you have many multiple terminals, then you can switch. In the installer, it behaves just the same. The installer, if you tonight, I want to install it again, okay? Because why? Today you will pollute your system, right? You think that the pollution is so horrible, okay? Just like the sky of Beijing, okay? You want to replace it, yeah. Then you can experience this. You can jump around different consoles. They are giving you different shells. Okay? So if you think that I don't know how to open a new terminal, okay, this is the way. New terminal. Only six. We call it virtual console. Okay? And go back here. This means that you are executing in this console number 1. You use change roots and change it to here. Is actually not affecting the second virtual console. Okay, so this direction is better. It won't change anything. Just changing your executing environment, you have a new root here. Now look at this directory structure here. Will exactly be the same as here with etc, with bin, with user directory. But now you change it here, and every change, okay, will be readable, but not polluting the outside world because you already changed the root. You cannot say, I'm in the root, can I do a cd ... You can try it. What happens if you are in the root and you try cd ... So what is cd ... Now this is a pwd. Okay, so this is a /boot I'm in. Maybe you are in another directory. Let's say you are in here, and this is /root. So I type cd ... Okay, it will go up one directory. Okay, so can you see it's already the end, the upper directory now. You continue to type cd ... What will happen? Is no happen. Nothing happen. Yeah, nothing wrong. Okay, you already on the top. You want to go through the top? No, this is already the sky. Okay, the sky is already the limit. Now let's go back to here. Hey, what is it? No. So now you change the root. When you type cd ... in this terminal, you cannot go back to here. Okay? So that means that if you do something less, let's say you extract the wrong folder, you didn't do the format right, then when you do the change root, sorry, reboot and do it again. Okay, so that's why last time so many people need to reboot again, because they missed some of the steps. Okay? Then the extraction, the emerge, they are not funny, right? Now today, let's do something funny. Last time we skipped it. Helen already prepared a file called vbox config or VMware config, and you change the name to .config. Today, let's see what are they. Okay, did you get your system ready? Yeah, if you don't get it ready now. Oh, why don't I use the full screen? Oh, wow. Thank you. Yeah, let's zoom in. Okay, zoom in is better. All right. Very hard to adjust. Come on. Okay. So let's do it. We will go to user source Linux. Okay. CD to there. You have that directory. Make sure that they contain contents. Okay, the content is something similar to this. I think that you didn't change anything, so it must be identical with my resource here. All right, then type make manual config. Okay, then you will get this. How many of you cannot get this? Yeah, if you cannot get this, tell me, okay? No, you don't need to tell me, you reinstall, okay? Okay,冇make file唔係嘛? No. All right. So let's take a look what it is. Oh, it says it is a kernel configuration. So remember, kernel is just a generic resource shared across a different system like ARM CPU. Why I cannot adjust this? Just adjust. Okay. ARM CPU, PowerPC, MIPS, Intel CPU. Okay. So this step is actually telling the kernel source tree what are the things that I want. Let's take a look at some of the things that you may understand. Let's go to file system. Okay, just up and down you can access file system. When you go to file system entry, press enter. Press enter. Then you will see some of the things here. It tells you that it will support extend 4 security labels, but it don't support extend 3 generally. Okay. Let's see whether it supports MS stores. Let's see. Any FAT32 support? Here, right? The DOS support. Go in. Wow. Thank you. Oh, nothing. See? It supports a DOS FS, a vfetch. Okay, this variable mean various kind of fetch. Default code page is so you cannot save any Chinese name. Okay. NTFS support is not there. It's not there. So it does not support NTFS. So how can you? Let's say I want NTFS support. How can you do it? Type spacebar. Okay. So what is the meaning of M? M means modularize. Modularize means that it is not in kernel. What is the meaning of in kernel? It's not compiled into the binaries called kernel. It's compiled as a file with extension .ko. That ko doesn't mean ko. It means kernel object. Okay, it's not kernel object .ko, and you can load it on demand. So when you put up, that means that it doesn't support NTFS. You have to load it. Okay, and you can see all the things NTFS write support is new. So what's the meaning? It's just newly know how to do write on NTFS. Because NTFS is proprietary. No one knows its implementation in an open source community. So they just can guess how to write it. Okay? Now it's already support, you can choose it. Oh, I want it. Okay, I want it. Or maybe I want a debug. Okay. Yeah, just like this. Now what Helen has done is actually she go through all the things, choose the correct things, and give the support to you. Okay, so what are the most important things that you first time, let's say you want to download this source code again, and you want to have this file created by yourself. The usually most important thing are the drivers, device driver. Okay. If you've done a driver, you cannot put up this machine, right? So you have so many device driver. I recommend you don't touch it. Okay. Helen already. I don't know how many days she has spent, but find the correct network card, find the correct display card for you guys. Okay, so don't touch this thing, but you can find many interesting things, like I square C. Wow, I square is very old. What are the things that you understand? GPIO, any CE student here? 冇 C 人㗎呢度 Sorry. A CE student need to write GPIO. Any things that you know? Watchdog, no. Broadcom, right. Broadcom has a specific support. Yeah, but you're not interested. Go away. Kernel hacking. Yeah. Even the print K and D message options, you have to set it by yourself. Okay. So let's go away. Okay. Don't touch too much things. Okay. Don't touch too much things. You can choose not to save it. Okay. Not to save it. I don't know what have you just typed, huh? Okay. I recommend you to choose no. Okay. So what is the difference between yes and no? Of course, yes, that means that you want the support. Now, if you check something yes and save it yes, okay, then your compilation time today will be much longer than other ones. Yeah, okay. Because you want more, right? Or you're too afraid, oh, what? Then you try to download Helen's .config file again. And where are they? The file is actually, oh, I don't need the L. Is here. Can you see this? .config. Minus A means that show the hidden file. So .config is here. Don't erase it, Erase it, you will have a big trouble because it's the kernel compilation configuration. Okay. So let's go back to the slides. So some years before, okay, when I was still a tutor, okay, I would ask students to do this config, okay, to let them to have a kernel panic while they are booting, okay. Yeah, well, I mean you don't want to see kernel panic, but today we will have a chance, okay. Right, we have a chance to see kernel panic. Device driver, file system, CPU mode, whether you want a virtualization support or inside, okay, you are welcome to go in there and see all the things, okay. I probably know more on file system and virtualization. Honestly, I'm not very good at. Okay, then you go through these three commands. This is compilation only. Okay, and this make install. Now remember, make install is very important. Okay, what you are doing is actually creating this file. Okay, let's go to the boot directory. Boot directory. The make install will overwrite this file. Definitely overwriting this. And this is you can call it the binary file, okay? The A.out. The A.out of our GCC output, okay? This is the kernel. It will override it. So make sure that you keep this clean, original. Whenever you compile the kernel, you get stuck, you inject some null pointer dereferencing, okay? You will only pollute this guy. Don't pollute this. And one more. Where's here? Okay, one more. The kernel modules. Okay, you will compile the kernel modules at this stage and install the modules. Where can you find the modules? The modules is actually at. I hate this zoom in zoom out. In /library. Okay, so many directory you don't know where it is. No problem. It is in CD modules. Okay, and you can find our version name, right? Although it is hard to see in the blue color. Okay, let me do this. Yeah, you can see this. 4.05. So CD into it. Then you will find the kernel directory here. The network card driver. This is the network driver. All the network drivers are already here. Okay, don't delete this file. You don't delete this directory. If you delete this directory, you cannot boot up the system, okay? Yeah, and as well as I cannot help you, I will tell you to reinstall. Alright, so this is the kernel modules. And then you install the bootloader in these steps. Okay, so there the bootloader, set up the root password. This FS tab, remember, don't pollute this FS tab. What is this FS tab? This FS tab is called final system table. The file system table hard code. Hard code what? Let's take a look. Really hard code. Go there. Here. Just use the editor to read it. I use Pickle, FS tab. Oh yeah, no, Nano. Okay, or maybe VIM is beautiful. VIM. No. Wait, didn't install. Okay, Nano. Okay, you can immerse and install it. Okay, so it is really hard code. Hard code the boot directory is actually mapping to the device. What does this mean? This means your second partition of the first hard disk. SDA means serial SATA hard disk. A, the number 1. Okay. Last time when you plug in a USB, it said SDB, so it's the second hard disk. Okay. This is the second partition, the third partition, and the fourth partition. They are hard code. Don't change it. Okay. You can change it. Okay, as long as you have more hard disk for this VM. All right. So I think this is the end of the debriefing part. Okay. Any question you want to ask? Okay. Don't ask me to try something dangerous yet. Okay. You will have a chance today. Okay. What is today's practice? I will go to the last page of this set of slides. You will try this. Okay. You will try to inject a new system call called terrible call, and the call is panic. You can try it, no problem. Just reboot the computer, right? Okay. I expect some good screenshot. Okay. One more interesting thing called bug on. Yeah, really bug on. All right. Yeah, really, I'm not inventing that. Okay. Its name is really called bug on. Okay. You can try this bug on. How bug on it is? You try it. Okay. You try it. Bug on. Yeah, interesting call. Okay. Okay. You can change it to whatever things. Okay. Whenever you evaluate to true, it will bug on. It's panic. It's bug on, and the referencing now pointer. So it's stupid call. Okay. Of course, these three are dangerous things, right? We will also try some normal things. Today I will introduce to you one very special global variable. We call it jiffies. Okay. It is the timer of the kernel. One is boot up, it's 0, and it will keep incrementing until you shut down the machine. This is a global variable. I want you to copy this global variable as a return value to the outside world to see whether it is really increasing or it just don't change. Okay, so you will try some normal things, but of course I know that you are not interested in normal things. You want to add normal things, especially this. Okay, yeah, the panic, you already know what is this panic. Alright, so these are the calls that today I want you to try, but you first have to understand what is the kernel source tree structure. Okay. Last time I already tell you some of the directories, what are their roles, what are their specialties, can you change this file, can you change that file? I didn't say anything, right? Now I teach you how to change the file, okay? So first of all, the header file is very important, okay? The header file in a kernel is basically cut it into very nice directory structure. We seldom touch this area and this area, okay? So what are they? One is the architecture-specific headers. We seldom touch them. Okay. Also, the drivers, don't touch the drivers. Okay. We only touch this area, Linux. So where is it? You can find it in the maybe I first wait a moment. I enable the SSH so that I can see clearly. Oh, I already installed this. Wait a moment. I can do SSH to it. SSH. What is the IP? 96. Oh, 96.102. Ah, right. Oh, come on, baby. What happened? Oh, wait. Yeah, great. I can SSH. How many of you have set up the SSH already? Yeah, I already show the movie in a group. Okay, you can follow my steps in order to enable SSH, so that we don't need to zoom or do some hard type things. Okay, we go to user source Linux and include directory. All right. So you will find all the directories here. I said that don't touch some of the dangerous things. Crypto, all things are very dangerous except the Linux. You are able to understand what is this. Linux. Okay. So this is for the kernel internals. The kernel's definitions, the structure definitions. Let's say the weight system call. How is this being defined? Weight.h. Okay, the weight system call definition is already here. Okay. So let's go back to the slides. I will show you something. First of all, this kind of a header file is very important. You know, header file, what are the usage? You never know, right? Because you never asked to write. Even in a data structure course, data structure course tell you, oh, you can set up an ADT using that way, and that way no one listen, right? You will hard code all the things. Someone tell you use a linked list, you use an array, okay? And yeah, now today you cannot avoid it, okay? Now basically, what are the header contain function definitions? Definitions. Some contain definitions. Let's take a look. Let's take a look. Where can you find definitions? Let's take a look at the list.h. Okay, we have the list.h. This is the kernel linked list. Double linked list. Yes, see? Simple double linked list implementation. Next week we will look at a very powerful generic linked list. Okay, it can host different types of things inside. Okay, and wow, what is that? Okay, what is that? Linux Poison, what is that? Yeah, I don't know what is that. Later I'll dig it up. Okay. Can you see? It contains implementation, right? Yeah, if you already know how to design software, you are told .h don't include implementation. Okay. Now kernel is doing another thing. It gives you implementations, some of the macros definition. Okay, macro definition. Some even using pointer. Okay, it's contain a lot of implementation. And this is something special about the kernel. Next week I will tell you what is so powerful about this. Okay, many of the definitions of the constants, exporting new variables that you create in a C file, so on and so forth. Okay, and let me ask you a question. This question is very important. Who don't know extern? Oh, you are confident. I only one say no. I don't know. Extern. Yeah, be more confident to say I don't know. Huh? Extern. Okay. For those who know, what is it? Jason, what is it? Okay. So when you say extern, usually where do you put extern? Usually. Header file. Okay. Header file for extern, and extern map to what? The variable. Okay, so Jason is giving me a very good examples of how to do a thing like I define a variable. You want someone to see it, you use extern. But basically, what we're talking about, right? You may understand better when you look at the code. Okay, so let's go to version 2.6. If you have downloaded the code, if you don't have, we can use the web browser to go there. It's kernel timer.c. There is a variable that today I will introduce to you called gfish. Okay, you will find a definition of gfish there. Let's go to take a look. Okay, so I will go to the browser. Okay, if you don't know the place is a free electrons. It's called LXR free electrons. Okay, so it's a Linux course reference platform. So you contain most of the things here. So because other codes are very hard to read, I give you the easiest to read version 2.4 around 15 years ago. Okay, so let's go to where is it? It is in kernel/timer.c. Okay, so kernel timer.c. Where are you? Timer.c, not time.c, timer. Okay, look for gfish. GIFFIES. Okay, so there is a keyword called volatile. Later on, when I talk about multi-processor code, okay, I will talk about volatile. Okay, so you can omit the volatile yet for the sake of easier understanding. You can find a definition here. It is a global variable. Okay, global variable defined in one of the .c file. Okay, in kernel, whenever you create a global variable in one of the .c file, it will go really global. Okay, so now you know kernel is very easy to write. You just define a variable. Okay, in a kernel source code any .c in a global variable part, then every other .c can see it automatically. Okay. Also for malloc, okay, let's say I create a global pointer and then I use that pointer to host a variable, and the variable is created by malloc. You can do this. Okay, so there's GFIS. Now, where can you find other GFIS definition? They won't happen in other .c now. It will happen in other .h. Let's say we go to this .h. So what is this .h? This week we don't have any lecture this week. Okay, I will talk about scheduler. So this is a Linux scheduler header file. Let's take a look. Okay, so we're still using this web browser. The header file is in. Go back to the Linux root directory. Then we will go to include, and then go to Linux. Include Linux. And then find the file name called sketch.h. Wow, very long. Come on, hey, search it. Sketch.c. Here. Okay, so this is the header file. So click on it. So you can also find a definition of GFIS. Okay, but with an extern there. So it's actually when you include this header file telling you that, hey, this variable exists elsewhere. But believe it, it is defined. Okay, believe me, it is there. So this is the use of the extern variable. Okay, so whenever you want to have to share multiple global variable to multiple files, you may create your header or just rely on existing header, add your variable names there with extern. Okay, so this is the use of extern in the kernel, and actually you can use it in your big project. All right, so the sketch.h, 2 weeks later we will revisit this header file because we will hack the scheduler. Okay, so that's why you will use this header file to understand the internal of a process, okay, as well as the scheduler. So this is the illustration. And where can you find something interesting? Okay, so let's check what exactly is this. What is it? Okay, this is a PID_T. Did you see this before? No one care, right? I know no one care. Okay. Look, man, fuck. Can you see this? No one asked this question because no one see man page. Okay, you guys just following my instruction. This is an integer. Okay, but actually the header, the manual says this is not an integer. This is a PID_T. Okay, so where can you find a definition of PID_T? Inside the kernel. I'm sorry, it's inside the kernel. So inside the kernel, you can look up such things inside include Linux types.h. Okay, so let's do a little exercise. We want to know what exactly this _kernel_PID_T. What is it? Okay, let's do a little exercise here. Find it out. I give it 5 minutes. Okay, I will do the same. So where is it? I don't know. So I will do the following. I have the download source code already. So that's why I said that you have to download source code. Let's do the 2.4 version of fewer files. If you want to take up challenge, go to 4.2.1. Okay. Yeah, and then I will do, what is it? It's called _kernel. What's the name, _PID. Don't type with me, okay? I'm doing exercise. You can also do exercise with me. Wow, what is that? Wow, what is that? Oh, I found it! I found it! I found it! Oh no, this is this line. No. Where is it? Did you find it? Oh, I found it. I found it. Did you find it? Yeah, I found it. Don't let you see. Did you find it? 5 minutes. Yeah, of course I have 15 years of hacking kernel experience. Okay, if I'm not faster than you, I'm useless, right? Yeah, can you find this? I will help. I just use the command called grab. Okay. Where was that? Oh, sorry. SSD 咯，好快嘅啫。我look 揾緊。哇！你逐句睇又唔係嘛？Don't read line by line, okay? We have millions of lines of code, okay? Use grep to find it. Can you find it? Google 答你唔到㗎。答到咩？咁得嘅你第幾行？哎呀，我輸咗啦。你第幾行？已經輸咗俾 Google。太恐怖啦！我輸咗。哇！你真係逐個睇又唔係嘛？那可以嗎？啊 right. Find it. You find it. I saw someone find it. Yeah. So that's why I said that with the code you know the truth, huh? You can dig up the truth using the code, huh? 有曲有真相，冇錯。Yeah, make sure that you can find yourself, huh? Okay, for search 嘛上邊 ，search 冇 free form 話 identify。會中 box 嘅就咁咧，佢係當你嗰個 search 嘅 input 係來自 standard in，所以佢而家唔係肥緊嘅，佢係停喺度，佢等緊你打 standard in。你要打翻嗰啲後邊。All right, can you find it? Yeah, you kind of find it. Yeah, although not very interesting, but tell you the truth about the system. Okay. So maybe we left you doing offline. So actually, I'm doing the search using this command. Okay. So I know that the keyword is kernel underscore PID underscore T, okay? And you know, define a type, right? Need the keyword type def, okay? So I just do a combo, right? First, find out all lines containing the kernel underscore PID underscore T, and together grab type def. Then just fly there. Oh, come on. Previously you were very fast. Come on, baby. Yeah, okay. Good. So we find all things. Now, basically, why did you find so many type def? It's actually as an integer defining this. Why there are so many things here? It's telling you that it's actually in the architecture-specific environment here. The Spark CPU, the 64-bit CPU, all different CPU has its own definitions. Okay, but it so happened that across all systems, it uses integer. Across any system, it's just use the integer to represent the type. Okay, so that means that you won't be surprised that maybe 10 years later we have a new architecture comes up, and that new architecture can define, let's say, unsigned long to become this PID structure. It's for that CPU. Okay, it is the how and why there is so many variety of the system that use Linux, because you can customize this for your own platform. Okay. So just change the header, then it becomes your platform. All right. So others is concerning scheduler. Okay. Later on, we will also take a look at this kind of scheduler specific things. Okay. Next week we will cover them. All right. So some examples you can find the keyboard, the double linked list. Even you can find a not so generic repertory implementation. This repertory implementation is for memory. Okay, when it try to allocate memory, it will try to remember the allocation. Okay, based on the address. So it want to have a fast search, so it's organized as a balanced binary search tree. Okay, so it's not so generic. Once upon a time, my F5 students, one of it, okay, he wanted to customize it into a generic version, okay, and he failed. Yeah, it's not because in Canton it's called git pick, okay. He really wanted to polish the code, okay. Really, you never see people have git pick, right? Git pick, 打 code git pick, okay. Very interesting guy, okay. I don't know who it is. Very horrible. Okay. So very short summary. This is a huge program. Okay. Big A.out. Okay. You compile it, become an A.out program, and you can even find main.c. Okay. Where can you find main.c? Interesting. Guess where can you find the main? Which part? What do you think? Where can you find the main function of the kernel? Which directory? Include? No. Init. Initialization. Initialization. Main.c. Okay, kernel has a main.c. Okay. Interesting, main.c. Let's go to the bottom. I just press big G to go to the bottom. Okay. Take a look. Wow. There's init functions. Okay. So this is the main function of a kernel. Okay. You can try to understand it, but I don't want to explain it. Okay, because you can say, wow, so many things. Yeah, you know, I told you before. Inside kernel code, when you find comments, then that means that it is horrible. Okay. You find so big comment. This is already big. Okay. Usually there are only one lines. Okay. Of course, there's other comments like you can find F. Yeah. I tell you a lot. Okay. A lot. Okay. Or a lot, okay, inside kernel code, okay. You can do a search, okay. But I some years before, some people tell me that we can look up this. I don't know who it is. Computer science, old names already, very old. Okay, when I entered CS department, we already have a domain chk.edu.hk. Yeah, this guy, I don't know him. Some others should be IE. No, IE department is gone. But there was an IE department email address there, but I cannot find it. Huh? Yeah, this guy. I don't know who it is. We call it a kernel maintainer or kernel contributor, whatever you want to name it. Okay, and look at the email address. Who will have this email address? You mean okay. I don't know. Maybe ask our admin. Okay, maybe one of them is. Okay, actually. Oh, you know me. Okay. Oh, this is me. All right. Yeah, the static. Okay, in kernel we have many static. Okay, in C++, you know the keyword namespace, but in C we don't have namespace. Okay, so we usually rely on the keyword static to keep something internal to your code. Okay, and that's why in the kernel code you will always find this kind of thing. Although the global variable that you write are having the same name, if you have a static and they are on different files, then this counter will only be seen by that guy. So this XXX file cannot access YYY counter and vice versa. Okay, with the static. And then when you understand that static means that you keep something on the same file, you will find the next natural integration of the use of static. Okay, now this is the header file. Usually we will use a header file with something like this. Okay, but I just said that no one's tell you to put in implementation inside header file, except previously we've seen this, right? Why is that? Because when you want to compile this file, XXX and YYY together into one binaries, these two header files, if you're following the lecture in a regular class, you will know that it's actually a copy and paste. What will happen when you do a copy and paste of this guy here and this guy here, and you want to compile these two files to be one binary, name collision. You collide with two same implementation of the hello function. So the next natural integration that you will see of the use of the static is not on global variable, but on function, static inline together. Okay, so what is static? Now you understand it is for namespacing. What's inline? Inline means that when a C compiler want to compile it, it won't treat it as a function. Okay, it will inject the compile code into the space that you call the function. Understand what I mean? Do you know the difference? One is to call the function. Yeah, the code executing. Oh, you want to kind of jump there. Okay. Inline means that you call some code and find out, oh, you want to call the function. You don't need to jump. The body already copy and paste into that area. Okay. So by experience, and not by me, okay, by experience is much faster than calling the function. Okay, so this is an empirical study, and that's why later on when you look at the kernel code, you will find a lot of static inline. And remember, inline, you put it alone there, it won't work for nowadays C compiler. Okay, and I look up the reason. The reason is when you just put an inline there, the C compiler don't know what is your purpose. You put inline. Then how about other files want my implementation? So it won't make it really inside the calling area. Whenever you put a static, then it knows that, oh, it is for this file only. So I can safely move the implementation in the place that you call a function. So usually you won't find inline alone. You will find static alone, but usually for global variables. Static inline, you will find it for header files or function implementation. Okay, static inline. And of course, there are some disadvantage, or every courses will tell you to use static inline. The disadvantage is the code is very big, right? Let's say the functions contain 10 lines of code, you call 10 times, so you inject 10 lines of code at 10 presence, so you make it into 100 lines more, okay? So, but no one care. Another things in kernel you will find is this guy. Yeah, assembly, inline assembly. So look at this. What is this code? It's a C code string copy inside kernel. Kernel's implementation of string copy. You can find it now. This is string.h. Yeah, it is in include ASM. Let's say i386 string.h. Okay, so this is string.h. See, string copy, string compare. Yeah, also a bunch of assembly code, and then boom, finish the string compare. String in compare. Yes, bigger. Yeah, with an N, so bigger. Okay. Yeah, all assembly code. So when you look at it, what happened? We call it inline assembly code. Whenever you write down underscore ASM underscore with the body count there, you can include any assembly code. One funny thing is that you can play with at your level. Okay, you don't understand this, right? Wow, what's that? It's a string copy. Okay, you can play around with this. Okay, so depends on your CPU. You can later on I'll give you a break. Then you can type this code. Do you know what this code is doing? With this comment, you may understand. Move means move some value with a dollar. That means that it is constant. A constant x011. Huh? No. L is for I mean old type of CPU. Now you guys all using new type of CPU, so you don't need the L. I try that. Okay? What is it? You test it later. Make sure you run this program. Okay? This program sucks, right? This is a function. Asks you for return value. Can you find any return there? No. But you can still compile it without any warning. And you can still run it and print some valid things. Very interesting. Okay, so now I give a short break, and Helen will come here to replace my position to teach you how to add system call. Now make sure that we will do something little by little. Okay, we first go to print something in what we call kernel debug message buffer, and it's a ring buffer. So what is a ring buffer? How many of you know what is a ring? Don't know what is a ring buffer? Circular buffer. Still a bit, okay? Ring buffer or circular buffer means that you have a finite space, right, for array. So when you keep writing NQ, okay, NQ, then you get full, right? Circular queue, yeah. Sorry. Circular queue, yeah. It's called ring buffer. Ring buffer唔係型啲咩個名啊？ Yeah. Circular queue sucks. Its name, right? It looks sexy. Ring buffer. Oh. Yeah, this is a ring, right? Ring buffer. Yeah. Or circular buffer, we call it. Huh? So, or your way to, what is it? A circular queue. Yeah, circular queue. It sucks. So many sounds. Circular queue. Ring buffer. Yeah, sexy. All right. So you will use this ring buffer, and this ring buffer you can find it in every system. This is my Mac. You can type D message. No. But as you do this message, like what? Yeah. See? What are they? What are they? Chrome sucks. Chrome trigger. And this increase system memory footprint until the target exists. So what is this? This is kernel debug message. And it's fine that this sucks program generates something bad and the kernel leaves the trace here. Okay? And let's take a look. Well, Mac is hard to understand, right? So let's take a look at here. This is Linux, D message. Now this type is easy to understand, right? At least we have colors. You can find one of the things that you may understand. Maybe here. Okay? What is that? NIC. Network interface clock link is how many bits? 1 GB, right? 1 GB duplex. So whenever a device coming into your system, it will generate some kernel debug message. Okay, and this is a place we call a ring buffer. That means that it's a finite space. If you print too much, it will run out of space, and the old message will gone. All right, so this is the ring buffer. Now I'll give you a short break, and Helen may need some time to set up. And during the meantime, you can try the inline assembly code. Okay, just write a simple C file, use GCC to compile it. Okay, and that's all. I tried it on Mac, no problem. I tried it on Linux, no problem. Okay, so Helen, your turn. Oh, by the way, let me stop the recording.